Okay, well, we are at time, so I'm going to get started. Welcome, everyone, and thank you so much for joining us today. I am Dr. Gwendy Reyes-Ilg, board member and the Director of Policy Development for the Veterinary Association for Farm Animal Welfare. For those of you who are unfamiliar with VAFA, our mission is to advocate for animals used in food and fiber production by providing a veterinary perspective grounded in animal welfare and ethics. We do this through education, policy development, advocacy, and collaborative animal care. VAFA currently has 3 areas of focus, which are preventing and mitigating pain experienced by farm animals, promoting living environments that meet the animal's physical and psychological needs, and ensuring humane end-of-life practices. If you're not yet a member of VAFA and would like to become one, please send us your name through the Q&A box located at the bottom of your screen, or visit us at www.vafaw.org. Membership is open to anyone who supports our mission, and the first year of membership is free. We are excited to launch the 3rd webinar in our series, Ensuring Humane End-of-Life Practices, with Jeffrey Hill speaking to us today about nitrogen anoxia-based methods of depopulation. Before we get started, I wanted to provide some context for the talk today. As you may know, depopulation refers to the rapid destruction of large numbers of animals in the event of a disease outbreak or other urgent circumstances. While it's sometimes referred to as euthanasia, depopulation differs in that it does not necessarily assure that animals are spared the pain or distress during the process. During the ongoing outbreak of highly pathogenic avian influenza, or HPAI, over 162 million chickens, turkeys, and ducks have died or been depopulated in the US. In contrast to other countries, the depopulation method most commonly used in the US is ventilation shutdown, VSD, plus heat, a method that causes death via heat stroke or hyperthermia, raising animal welfare concerns. The USDA reports that VSD plus heat has become the primary depopulation method for commercial egg farms in the US. And based on USDA data through January 2025, over 71% of birds were destroyed in depopulations in which VSD plus was used either as the only method or as one of multiple methods on the same premises. And in over half of the barns in which VSD plus heat is used, some birds survive, and the USDA reports that it may take up to 5 days to find them and their lives. VAFA is committed first and foremost to decreasing animals' vulnerability to depopulation, for example, through vaccination. And we also work to advance higher welfare methods when depopulation is unavoidable. In line with this, we are very fortunate to have Mr. Jeffrey Hill speaking to us today about several innovative nitrogen-based methods of depopulation that aim to protect animal welfare while still being practical for use on commercial farms raising chickens, turkeys, ducks, and pigs. Over his 30-year career, Mr. Hill has held positions in production agriculture, the meat processing industry, engineering services, government affairs, research organizations, and regulatory services. In 2020, he founded Livestock Welfare Strategies, or LWS, and later LWS Canada, which offer consulting services driven by the principle to optimize the animal's quality of life by encouraging positive experiences while minimizing stress and eliminating distress. Mr. Hill has guided numerous organizations in over 20 countries through the process of planning, preparing for, and responding to livestock emergencies. VAFA is also fortunate to have Mr. Hill on our board of directors. After Jeff's presentation, we will follow up with a question and answer session, and you can submit your questions throughout the webinar using the Q&A button at the bottom of your screen. And we will address as many of these as time permits. So now, Jeff, I will turn it over to you.
Thank you, Gwendy.
I'll give you a moment to get your screen up there. I'll let you know when it's there. Okay, we can see your presentation, but not in the kind of in the format where we can see. There we go. That's
There
all.
we go.
Great. Thank you.
Well, thank you, everybody. And I'm hoping this helps you understand and be introduced to some new methods for depopulation based on nitrogen due to nitrogen exposure. Um, as many of you, was going through some of the names. Many of you are familiar with this work. We've collaborated in the past on different projects. Because as Wendy said, LWS works, researches and develops euthanasia, stunning, and mass depopulation technologies, and has for over the past 25 years. We work with poultry, swine, and cattle, and currently have 9 projects in 4 countries, looking at nitrogen whole house gassing, high expansion nitrogen foam, some electrocution for both poultry and swine, and advanced captive bolt technologies. So just to understand, with this many years of experience, there's not very many methods, either good, bad, or ugly, that we have not been involved with. Gwendy mentioned this. What is depopulation? And hopefully everybody is familiar with it. But AVMA currently defines it as the rapid destruction of a population of animals in response to urgent circumstances, with as much consideration given to the welfare of animals as practicable. That last statement, as practical, is what makes this a very controversial and very difficult area to research and develop new technologies. Just to highlight, if you're not following, AVMA guidelines for depopulation of animals are currently going under revision, and they were open up for comments throughout January. Um, and I happen to sit on the subcommittee for poultry depopulation on this as part of the working group. And depopulation now refers to the implementation of a unique, large-scale emergency or disaster management plan involving the rapid termination of a population of animals with the least amount of negative welfare impacts to the animals. But WOA defines it slightly differently. They define as killing, as means of a procedure that causes the death of an animal. And when this is done for disease control purposes, the methods used should result in immediate death, immediate loss of consciousness lasting until death. When consciousness is not immediate, induction of unconsciousness should be non-aversive or the least aversive as possible. And it should not cause avoidable anxiety, pain, distress, or suffering in the animals. And this highlighted area is really where we've been targeting our work in the past few years. Depopulation is moving away from individually applied methodologies into group aspects, and that is for many reasons, including efficiency, you know, operational issues, cost, protection of the operator, both physical and mental. Why do we do depopulations? The most obvious one was just talked about, foreign animal disease. We're talking about high path recently, high path avian influenza. But we have a tendency as an industry to get focused on what is occurring right now. You know, high path, we've been fighting this wave since 2022, but there are numerous diseases out there, and we will see those in the future. But it's not limited just to foreign animal disease. A lot of depopulations are done due to production limiting disease. We've done many PED, many PRRS depopulations in the swine industry. Natural disasters, you know, fires, floods, um, those that we have very little control or no control over. Economic situation, and this could be a border closure, currency devaluation. I was involved in an isoween piglet depopulation strictly due to the piglets not being worth the cost of transport. And that depopulation accounted for almost 3 million piglets. Social constraints. This one was highlighted during COVID. We had many processing plants shut down due to the lack of employees and the restrictions on spacing of employees, and that resulted in both swine and poultry being depopulated. And production management methodologies. And I've highlighted here spent hens, and I've highlighted it in yellow because with the new definitions for mass depopulation, these no longer should be considered mass depopulations. But yet, as we move to aviary production systems and enriched systems, we're looking at larger group depopulations due to the facility designs. Aviaries are not conducive to individually catching birds, and it has resulted in significant animal suffering, but also significant human injuries for catch crews as they climb up and over the aviary systems and fall to the floor. So we'll talk about nitrogen gassing, using nitrogen gas for euthanasia and depopulation of livestock. It is considered the gold standard worldwide, and it has been studied extensively for slaughter specifically, but also euthanasia and some work on the depopulation for poultry and livestock. It has been evaluated and deemed acceptable worldwide. Why is it? Nitrogen is an inert gas. It's physiologically inert. Our bodies do not react to it. If we did, because the environment is 78% nitrogen, we would be reacting to the environment constantly. It's odorless and tasteless, and the birds and livestock do not have chemoreceptors responsible for responding to for nitrogen as an inert gas, and therefore it does not cause aversive reactions. However, there is some concern with the risk of oxygen deprivation because your body does respond when oxygen gets between around 10%. And that is why the critical factor when we're looking at use of nitrogen or any inert gas that limits oxygen uptake is at 6 to 10%. And that's where anoxia versus hypoxia becomes critical in our discussions. Anoxia is when no oxygen is supplied to the organs, and loss of consciousness is the first clinical sign, and it results in very rapid death. Versus hypoxia, and this is a slower decrease in oxygen, where your oxygen demand of the body exceeds the oxygen supply of the environment. It's a much more gradual death, and dyspnea is the first clinical sign. And we'll talk about the different methods. Some nitrogen ones are anoxia based, others are hypoxia based. Previous research on nitrogen has shown unconsciousness and ultimate death was induced without indications of distress when nitrogen was introduced and oxygen concentrations maintained at less than 2%. However, effectiveness of using nitrogen can be impacted by many factors, most primarily the nitrogen concentration being injected or added to the environment. It is critical that you're using high quality, high concentration nitrogen because your injection rate will be very, very different if you're using a 99.8% purity versus a 95% purity. The rate of injection, quality and temperature of the gas, duration of exposure, even ambient weather conditions can impact how nitrogen vaporizes and permeates throughout a facility. Design and operation of equipment, and even the density of animals. And we have also recently found more differences when we look at age of animals and species of poultry. Collectively, the research data has clearly demonstrated that nitrogen is less averse than CO2 and offers a significant welfare refinement for the depopulation of livestock and poultry compared to the methodologies currently used. When evaluating different depopulation methods, use of nitrogen has scored the highest on animal welfare scoring when it's evaluated by expert panelists, including veterinarians, animal welfare specialists, and engineers. However, use of nitrogen as a mass depopulation methods continues to be researched, and these methods that we're going to talk about, a lot of them are in their infancy, and they're still being refined and developed. And we'll talk about some of the differences we've seen even in the last 6 months on some of the methods. Then the question becomes, why haven't we been using inert gassing for depopulation? Well, two main reasons. One, the AVMA guidelines on euthanasia, depopulation, and slaughter provide inconsistent guidance on the use of nitrogen gas, but it historically has not been used for mass depopulation because the original research done with gaseous nitrogen had issues. And this was 40 to 50 years ago. And as researchers, we failed to go back and review and refine this technology because it was always been said it was impossible to seal the barn to an extent required to adequately eliminate oxygen to less than 2% level. Since nitrogen is basically the the air is basically 78% nitrogen, we're not going to be able to control the gas flow and distribution throughout the barn. It's basically going to enter, rise up, and disappear. Therefore, the amount of nitrogen required would be tremendous, and it would take a long time for the wash in, wash out process necessary to reach and maintain the 2% oxygen level. The time required to fill the barn with sufficient nitrogen to ensure less than 2% oxygen would be extensive and would not be practical. There was the concerns for oxygen deprivation and the potential for freezing animals when using cryogenic gases. However, in the last 5 years, there has been extensive refinement, development, and commercialization efforts for nitrogen depopulation. These include high expansion nitrogen foam, using whole barn systems for poultry, and then containerized systems for poultry, swine, and cattle. Whole house nitrogen gassing, using direct injection of liquid nitrogen, and then whole house nitrogen gassing using gaseous nitrogen, and then containerized gassing for both poultry and swine. We're going to talk about these independently, and I'm also going to try to give you multiple examples. And I've tried not to highlight any one manufacturer. I've tried to include many different manufacturers so that you could see the differences, but most of the systems work primarily in the same manner. High expansion nitrogen foam. To me, this is the most exciting technology available today. It is so flexible and adaptable, and it's so easy to utilize. It can be applied to multiple different species. It's currently approved for poultry, but there is further research needed for cage poultry, but that work is ongoing, and we're seeing tremendous development in that field. It's been demonstrated effective for the population of swine, and it's recently been used for cattle, sheep, and goats. It can be used in a wide variation of building and container designs, and it eliminates the need for ancillary operations, specifically sealing the container or the building. And death has been shown to be due to anoxia from exposure to nitrogen gas. So it is considered an inert gas system as the foam bubbles are only a delivery agent of the gas. The bubbles surround the animal, and these bubbles are filled with nitrogen gas. They're very large bubbles. They're large enough that they cannot enter the trachea. And what happens is as the animals pop the bubbles, or if it's popped, it may be also popped by an injection of nitrogen gas, it rapidly displaces all the available oxygen and surrounds the animal in a pocket of nitrogen gas. The other benefit because the foam is heavier, it will expedite the wash in, wash out factor of nitrogen of that container. These are some different examples. This is a LiveTech system used with poultry. It's been shown effective with broilers, layers, ducks, and turkeys. Mean time to loss of consciousness was 30 seconds in hens and 18 seconds in broilers. Isoelectric EEGs were 47 seconds in broilers and 67 seconds in hens. So very rapid loss of consciousness and rapid death. And there was no inclusion of the airway, which validated that its mode of action is anoxia. This is an example of a barn filled with foam with birds underneath. The HEF system, slightly different, and we'll talk about some of the specifics, but this is a containerized high expansion nitrogen foam system. For turkeys, they saw loss of posture beginning at 37 seconds and all loss of posture completed in 11 additional seconds. For chickens, this was 46 seconds with all loss of posture in an additional 12 seconds. Sensation of movement for turkeys was slightly longer at 200 seconds compared to chickens at 120, but still very rapid sensation of movement, loss of posture, and death. In swine, this is an AES system, and it's been shown 100% effective success rate for piglets, feeder pigs, market hogs, and breeding animals. Pigs exposed to nitrogen lose posture within 60 seconds. The median activity intensity is at 37.5 seconds. Sensation of movement averaged 100 seconds post start of foam filling with a rapid onset of bradycardia with sensation of sinus rhythm. Pigs show no strong aversion to foam when they are placed in a foam in the container. However, methods of introduction are the area that we see continuous improvement. The AES system, which you see down in the bottom, that will fill this 48-foot container with 4 foam generators in just about 15 seconds. So we were seeing where 2 years ago, it was 2.5 minutes to fill that. This has resulted in elimination of vocalization and minimization of escape attempts because the units are brought, the foam generators are started, they are brought over the container once they are fully running because pigs, what we have found, react to the noise of the foam generator when it's during startup. So by starting them prior to bringing them in the pig's area, the pigs have a much less reaction. With any high expansion nitrogen foam, bubble size is critical. So with pigs, we see a presence of foam in the mouth and slight entrance into the trachea, but no evidence of occlusion. It was recently described as providing a rapid destruction of a population of animals, giving significant consideration to the animal's welfare, therefore meeting the AVMA definition of depopulation. These are just the basic elements of the nitrogen foam delivery system. You'll always have a nitrogen supply tank. This will either be in liquid form, liquid nitrogen, LIN, or gaseous nitrogen. If you're using a liquid nitrogen, you'll have a vaporizer, and this could be either onboard nitrogen foaming system integrated into an AES or Livestock system, or it could use a nitrogen pumper truck, which is supplied by industrial gas companies. You'll have a water tank supply tank, a foam concentration tank, and usually concentrates run from 1 to 3%, and then your control pumping and distribution system, and your foam generators. If you've never seen high expansion nitrogen foam, I thought I'd show this quick video just so that you can see how different it is to the medium density water-based foam normally utilized for floor-reared poultry depopulation. It has an expansion rate of a minimum 300 to 300 plus, so it fills a volume very, very rapidly. Its bubble size should be at least 20 millimeters and larger bubbles for larger animals. One of the benefits of high expansion nitrogen foam is its capacity for depopulation. Here is just an example that we modeled a 10,000 sow depopulation using nitrogen foaming. A 10,000 sow farm will have approximately 35,000 pigs on it when we include our sows, our gilt developments, and our piglets. And to depopulate this farm using just farm labor to move animals and load trailers, and then 5 trailers in rotation, it would take us approximately 14 hours to depopulate that farm. When we look at it in a poultry facility, a 60 by 600 foot broiler barn would require approximately 22 minutes to fill to the depth of 1 meter, and utilize about 30 gallons of concentrate and 141,000 standard cubic feet of nitrogen gas. There's multiple different systems available in the US and worldwide. These include the AES, or Agricultural Emergency Services, based in the US, Livestock Systems out of the UK, Heft International out of Sweden, the RDA out of South Korea, and then there's also some other ones that have been developed in Bulgaria and Eastern Europe, specifically for ASF response. I'm just going to highlight some of the major points. AES system was designed specifically or originally for swine, and it has then been used for poultry. It is a rapidly deployable system that it's a very simple system. It's based on the concept of the fire trucks, where every operation is manually controlled. It has a flow meter and a valve on it, so it uses readily available components. It has the highest capacity foam production currently available. It can operate up to 4 foam generators simultaneously, and that rapid fill time helps reduce time to loss of sensibility and death. You can see over here in the bottom corner, this system has been used to demonstrate how far we can stack this high expansion nitrogen foam, and we can easily stack it well over 30 to 50 foot high. It currently is based on using a nitrogen pumper truck, which is I believe, the limiting factor for this technology, but they are currently testing an integrated liquid nitrogen vaporizer option. LiveTech system was the original system on the market, and it's very similar to the AES. It was designed originally for poultry and then expanded into swine. It can only operate 2 foam generators simultaneously. Therefore, it takes can take up to twice as long to fill a container. The big difference is this is a very highly automated system. It's PLC controlled with electronic valves and remote monitoring and control capabilities. This system currently uses the liquid nitrogen pumper truck, but again is integrating a heated vaporizer unit into their system for commercial markets. Heft is a very different system. It's high expansion nitrogen foam, but it is a containerized system. It was originally designed for euthanasia and has expanded into slaughter and depopulation. It uses a very high expansion foam of 800 plus expansion rate, and then it uses a blast of nitrogen gas to burst the bubble matrix. And what this does is it ensures when that nitrogen gas is blown in, creates immediate anoxia conditions, and then you have immediate loss of sensibility and rapid death. They have developed their own proprietary foam. It has excellent flow rate or excellent bubble size. It is transparent, but it does limit its flow rate. So it can be an issue on the size of containers you can utilize. The nitrogen can be from compressed gas cylinders, nitrogen generators, or vaporizers. The RDA system is a very similar unit. It's a much smaller unit. It uses cylinders of nitrogen gas, and then they utilize and fill small pits or containers, as you see, dug into the ground. They designed it specifically for AS or foot and mouth disease, and have used it for ASF, but have also used it and demonstrated it for poultry. The interestingly, they did highlight, and we've talked in that how much more efficient and cost effective it is than CO2 gassing. Moving on to nitrogen-based whole house gassing, and we're going to talk specifically about liquid direct injection first, which is where I've spent the last 3 years of my life working. But before we want to talk about the properties of liquid nitrogen, because as I said, historically, nitrogen has never not been used for whole house gassing or mass depopulation of any method. But liquid nitrogen consists of pure nitrogen molecules in their liquid state. It's very, very pure, 99.99999%. But it is very, very cold when it's under compression, minus 320 Fahrenheit. The benefit, though, is as it expands up 175 times its original volume when it becomes gas, and it expands another 3.7 times as it warms to room temperature. So we get a very rapid fill up of a facility due to a total increase of volume of 645 times when we go from liquid to barn temperature. It is these gaseous properties and the density aspect that allows us to control the flow of the nitrogen gas throughout the poultry house. Other benefit is liquid nitrogen is readily available throughout North America. It is a primary industrial gas. It is not like CO2, where CO2 is a secondary gas from a manufacturing process such as fertilizer ethanol. It is pulled out of the air and then utilizing air separation units and then liquefied. So it is much lower cost than CO2, and it is a very efficient and cost-effective to transport due to its density. The nitrogen whole house gassing efforts began when CO2 became limited worldwide during the COVID outbreak. There's been work done in Italy, with the butane model, in the Netherlands, in Canada, and now we are starting a project with the Minnesota Department of Agriculture in the spring. When we're looking at liquid injection model, the operational theory is very, very simple. It utilizes liquid nitrogen discharged from a transport trailer through a single hose into a distribution manifold that feeds subsequent pipes into the barn. Heat in the barn, especially the floor, it's about 70% of the heat comes from the floor, provides the heat required for vaporization from a liquid to vapor state. This transfer of heat from the floor is very, very efficient, and it therefore results in minimal impact to the overall barn temperatures and basically no impact to the floor temperatures. And we have actually cored into the floor and taken multiple temperatures throughout the floor profile, and we see a maximum of 3 degrees Celsius difference. Nitrogen gas that is vaporized from liquid state is cold and therefore is much heavier than air. So when we're doing liquid nitrogen injection, we inject it in. As it vaporizes, it spreads horizontally across the barn floor and it replaces the O2, resulting in anoxic conditions along the floor. But as it warms up, it starts to rise throughout the building and forces the barn environment out the ventilation and creates an anoxic condition throughout the entire facility. The betaine model in Italy was developed strictly due to lack of CO2. There was very little testing of it done because it was basically a necessity for responding to HPAI. You can see here the liquid nitrogen transport trailer, a single hose that then attaches to the distribution manifold down here at the bottom, and three 5 centimeter HDP pipes enter the barn and are placed at 1/4, 1/2, and 3/4 of the barn lengths. These hoses are aimed up at a 5-degree angle, and nitrogen is slowly discharged into the barn for approximately 100 minutes. It requires approximately 2 times the volume of the barn of liquid nitrogen. Very simple system, but currently it has been shown to be more effective than their commercial CO2 whole house gassing performance, well over 99% effective. That was the initial program. Canada, because Canada does not allow ventilation shutdown plus or medium density foaming for depopulation of poultry, decided to evaluate nitrogen whole house gassing as developed in Italy. And so we've been on an extensive research program, and we've evaluated with floor-birds, conventional cage system, enriched cages and aviaries. We have to date have done approximately 20 research depopulations, including broilers, broiler breeders, spent hens, and tom turkeys. And then we have done 6 commercial depopulations, trying to replicate how it would be done in a response scenario. We've evaluated environmental, physiological, and behavioral impacts, and this has been extensive. Monitoring of environmental conditions at all 4 quadrants and then the center of the barn. And we're going from floor to ceiling, looking at relative humidities, concrete temperatures, oxygen levels, carbon dioxides, and barometric pressure. We've mapped the nitrogen liquid gas vaporization process. We've done animal behavior monitoring and auditing through visible and thermal video imaging. Done body surface temperature, veterinary evaluations for all sites, including full necropsies. And then we have begun doing star OD implants, which give us heart rate, body temp. That final report for the first program will be coming out in the next month. But what we have found is as we move forward, we've begun to develop SOPs and operational procedures. So we have found that the balancing of the liquid nitrogen injection rate to vaporization rate is the key. When we originally started, we were injecting much too fast, and it wasn't having opportunity to vaporize and spread throughout the barn evenly. We have moved to a quad distribution system, which utilizes 4 1-inch HDP pipes, and we're currently now testing cryogenic hoses versus HDP piping. This was done strictly due to the environmental conditions found in Canada during the winter and trying to handle larger 2-inch HDP piping. Securing the pipe distribution system is critical because as the nitrogen vaporizes, there is pressure produced. And you can see down in the bottom corner, this is the simple system we have developed. It is simply a weight that attaches to the end of the hose, and that is how we secure it. By doing this, it allows the HTP to retract as it gets cold, which it will do, but not to move that hose around. It keeps the hose placed in line where we put it. We target a 3% O2 above bird level. And we have found that if we do a 5-minute slow ramping up of the liquid nitrogen, we reduce bird reaction instead of going straight from no flow to full flow. We use a minimum 15 psi and a maximum 35 psi liquid nitrogen flow. You get below 15 psi, you can freeze up your lines. And the trucks in the liquid nitrogen transport trailers in Canada have a blow off system that is set at 37 psi. So if we go above the 35, we'll have the blow off valve go off. We have developed a standardized liquid nitrogen usage and flow rates based on barn size, and that is 0.2 standard cubic meters of nitrogen per square meter of floor per minute. We have learned that overgassing is not beneficial. We started off overgassing facilities, and it does not improve your performance. All it does is increase your usage of liquid nitrogen. It lessens your operational efficiency and decreases facility temperatures. A short dwell time is all that is required. We have found 3 minutes is sufficient, but we currently target 10 minutes because that's approximately the time it takes for us to disconnect the transport trailer from the piping system. Here's an example of the nitrogen or the oxygen concentration decrease as we inject nitrogen. We began injecting at 11:20. We had a 5-minute ramp up period where we slowly inject and keep increasing our injection rate until we're at full flow at 11:25, and we ceased injection at 12:15. Just so everybody knows, we have transitioned to a wireless monitoring system by Cortex Agri-Technology, and it has been so beneficial. It's reduced our setup time from 8 hours to just under 30 minutes, and our cleanup time from 4 hours to less than 30 minutes. Here is a calculator that's been developed, and it's a live calculator where you can put in your barn size, and it will calculate all the operational parameters, including injection time, replacement rates, all the information that you would need. And our results have shown that nitrogen gassing should cause the death of all animals within the facility. It does rapidly create anoxic conditions within the range of facilities evaluated, and these have been a very large range from 200 head up to 40,000 head. And we have done it in a range of weather conditions experienced in Canada from minus 30 Celsius to plus 30. Birds begin losing sensibility between 10 and 8% oxygen. We do see some slight species differences between chickens and turkeys. Loss of sensibility occurs before the reduction of environmental temperatures. And we average, utilizing the barn ventilation system, an 8 degree Celsius barn temperature after the nitrogen whole house gassing process, which is very close to what the Italians found. We have complete loss of sensibility at approximately 6% oxygen. Then we have post-reflex activity movement after loss of sensibility that remains for approximately 4 minutes. And we have seen when we follow this program that we have developed, we see no physical or structural damage to the facilities. This is just an example, and I apologize, it's very busy, but I wanted to showcase where the oxygen hits 10%, then 6%, then 3%. And you can see the temperatures, the CO2 levels, and the pressures. But very, very rapid decline. What is very different, and I highlighted this, I picked a quote from Dr. Mike Petrick, who came as an observing veterinarian. The birds observed during the process to be perching, foraging, preening, and walking about calmly. That is the difference you will see versus a CO2 or a VSD plus. Once they have a quicker or a small reaction to the gaseous injection, and we've reduced that by doing a slow injection period, then they go back to their business. Dr. Thompson said nitrogen whole house gassing is certainly the most humane method of depopulation that I've ever experienced. And what I like to point out, look how nice and even that distribution of birds throughout that facility is after the process. I'm going to attempt to show you a video for a depopulation of a barn size that's 267 by 33 by 14, where the liquid nitrogen goes on just at the beginning of the video and off at 9:45. Honestly, it's extremely boring. And I'll probably jump forward, but you'll see here in a second, the birds will react to the nitrogen coming on, and then they go back to their business. You'll see them look up.
Jeff, we can't see the video yet. I don't know if you're,
Oh,
no,
okay.
we just see the slide
Sorry.
deck.
Thank you. Let's try this again. Can you see it now?
Yes.
Oh, yeah, now we can.
Sorry about that. As I said, it's not very exciting. And we'll jump through it, but I just wanted you to see, you'll see the reaction of the birds as the gas is initiated, and then they'll go back to their business. It's understanding that I have spent thousands of hours sitting and watching these videos and recording behaviors by minute. So here we go. And this gas would be injected at slow rate to begin with. So there's very minimal reaction. And this is also one of our earliest. This was the fourth depopulation. It was done a year ago. And actually, we see much less reaction now that we've gotten better at controlling our gas flows. So the gas is running. Liquid nitrogen is being pumped into the building. Now we are 6 minutes later. You see they're just moving around. No reaction to the gas, no reaction to the reduction of oxygen. There's 9:30, so 10 minutes after it started. We're starting to see some reaction, but very, very minimal. I apologize. It's not the easiest program to get to. Now we have birds going down. This is 9:35, so 15 minutes after the process began. Oops, we lost the sensibility. And now we're pretty much lost the sensibility, and now we're going to reflex action. 9:36 is where they start to lose sensibility. But you can see just how calm those birds are. There's 9:42, all full loss of sensibility. If you continue to play it, you will see post-movement, post-reflex movement after they've lost consciousness. Okay, just due to time, I'll stop it there. Hopefully that gave everybody an idea of what we normally see. Because it actually now, due to our study and evaluation of the gas flow, we are seeing less and less reaction. Current project status, the initial research efforts are completed. SOPs have been submitted on nitrogen whole house gassing. We've developed the calculator. We've developed industrial gas supply company SOPs and safety programs. And our final report should be due in March. And then we will begin, or we have begun, a nitrogen optimization project. We'll be looking at different liquid nitrogen distribution systems, addition of manifolds, vaporizers, etc. Now we move on to nitrogen-based whole house gassing using gaseous nitrogen, not liquid nitrogen. The previous one was direct injection of liquid nitrogen. This is using a vaporizer to turn liquid nitrogen into a gaseous state. And basically, you can see the first testing was done with these dewars. It requires vaporizers that are heated so that they can meet the required flow rates and pressures. And it requires approximately 3 gas replacements of barn volume to achieve these 2% O2. The ejection times take approximately 60 minutes. And it is possible to create the anoxic conditions throughout the barn. The big difference, because we don't have the density of the cold nitrogen, we have to maintain constant air movement to mix the nitrogen throughout the barn. This minimizes stagnation of the nitrogen gas in the barn. The benefit of this is there's no concern for cold temperatures in the barn or impacts to the animals. Here's an example of the oxygen. As you can see, it takes approximately 30 minutes to reach the 3% level and then stabilizes. That work is ongoing, and more commercial work will then be based off of this effort. But it has shown it can be done and can be done very effectively. We look at nitrogen-based containerized gassing systems. Containerized gassing systems, sometimes we call them MAC carts, that utilize inert gas, have been around for decades. However, they have become much more commercially utilized due to the CO2 shortage due to COVID. Just as an example, this is the Livestock system down here that uses a argon CO2 gas mixture for commercial operations for the depopulation of poultry. The one thing to keep in mind is gas mixtures. If you are going to use a CO2 argon, or CO2 nitrogen mixture are not available in bulk liquid form. So you either have to use cylinder gases or mix your gases on site. The benefit of the CO2 inert and inert gas combination, while there are some welfare concerns, it is easier to manage because it is heavier than air. This is an example of a Manitoba pork depopulation trailer. Why I highlighted this is a fully self-contained unit. It is for the depopulation of isomene piglets and feeder pigs, but it has its own nitrogen separation system at the front of the trailer. So it separates nitrogen from the air, fills the tank, and then injects the nitrogen into the animal area. The issue with this unit is the cycle time is 60 minutes, and it must be moved away from the chute to unload carcasses. So you load them from the back, and then you unload carcasses from the back, so you have to pull it away. That system led to the Ontario nitrogen trailers, which are very similar in design, but they decided not to utilize liquid nitrogen separation. They use a nitrogen vaporization trailer, which they can receive liquid nitrogen, vaporize it, and pump it into their depopulation trailer. This allows it to have a much higher capacity for animals, and it then therefore loads pigs from the rear and unloads carcasses from the front using a transfer conveyor. This reduces its cycle time to approximately 30 minutes, so it's twice as fast as the Manitoba trailer. I'd like to conclude with just a few future opportunities that I see and hopefully we can talk about. We are moving forward with further refinement of nitrogen-based depopulation systems. They have shown they can be very, very positive. They are effective, efficient, and humane, but we are still learning. But what I see as the biggest need is that we should be planning for mass depopulation in the design of any livestock or poultry production facility. And I'm hoping, and we actually have interest from layer companies, egg companies, to integrate mass depopulation systems into their facilities because they are utilizing methods for routine depopulation of spent hens. And if we can integrate those and have all the plumbing and everything in the facility, it makes it much simpler for routine depopulation. The next step from that, and what we're doing there, is actually looking at piping that we can then just hook a liquid nitrogen truck right up to. It's all in the barn. Let the hens go to sleep at night. Start the system. Let it run for 40 minutes, an hour till it reaches 3% oxygen. Then shut up the system, secure it, and leave it and clean it in the morning. The next step from that is development of and implementation of fully self-contained depopulation systems within large-scale production facilities. And this would be putting a liquid separation system directly in the center and being able to plumb out to multiple barns for mass depopulation or depopulation of spent hens. Nitrogen separation systems are readily available. They're on the market. They're used in commercial applications on a daily basis. And that is an opportunity to remove the setup time, the planning setup, preparation times, and let you depop within minutes, start your depopulation process. I would like to encourage the industry to implement depopulation systems that support or enhance production capacities. Example would be if we're using a liquid nitrogen separation system that then liquefies and tanks the nitrogen. We could use this for animal cooling. It's a cryogenic gas or cryogenic liquid. We could plumb it through our buildings and basically use a reverse radiator system to cool the animals. We could use the nitrogen for fire suppression. So it's taking it beyond the thinking of just responding to an emergency. It's preparing and being fully equipped to respond. And because I'd like to remind everybody, just because the animal is dead doesn't mean it was done right. And with that, I'd be happy to answer any questions.
Thank you so much, Jeff. Before we transition to the Q&A, I just wanted to give our audience a quick update from the last webinar where we mentioned some of VAFAW's advocacy efforts related to depopulation. As Jeff mentioned, in November, the AVMA released a draft of a revised edition of their depopulation guidelines for comment by AVMA members. And VAFA hosted a sign-on letter that was supported by more than 860 veterinarians and vet students, including more than 500 AVMA members, which asked for key changes to the guidelines to improve farm animal welfare. In addition, VAFA submitted our own more detailed technical comments. And if you want more details on that, check out our advocacy page on our website. So now I'm going to transition over to questions. We had quite a few. I've tried to group them by the topic, whether it was related to foaming or gassing. So first question is, how hard is it to source the nitrogen gas and the foam? And then specifically for nitrogen foam systems, are there any issues with the speed of deployment of these systems? They're asking about lag times associated with sourcing vaporizers and other equipment required. And I suppose this would be in facilities that don't have on-site capacity.
I was going to just let this thing run in the background when we talked, but I've lost my control. So that's not going to work. Liquid nitrogen is readily available. It's an industrial gas that is used in every application you can imagine. And we've done evaluations in even remote areas of Iowa and Minnesota. We can get 10, 15 different delivery companies. The big limitation has been the nitrogen pumper trucks. Those are very available in North America. There's approximately 600 of them in the US. The problem is they're in petroleum-based areas. I can get as many as you want in Texas, Alberta, not a problem. Louisiana, but the Midwest is not serviced by them heavily. So we've had to bring those in from, I think the closest we ever got was Gary, Indiana, but most likely Louisiana or the East Coast. There's a lot of them there. And that is why all of the manufacturers are looking at integrating a vaporizer directly into their nitrogen foaming system. So all you'd have to do is hook up a tanker of liquid nitrogen, and you've got unlimited capacity.
Right. Another viewer here is asking, with the foam systems, does it make observation of the animals being treated difficult and therefore make it difficult to assess welfare?
It does, and we use video, we use auditory, but we've really begun relying on a lot of the implants, and we're even using the implants for an audit tool as we're doing depopulations. That information is incredible for a learning aspect. Every time we do one, we learn more and more. The foam from Heft, which is a proprietary foam concentrate, actually is very translucent. You can see the animals through it, and it was designed specifically for that purpose.
Great. And I guess maybe kind of tied to that question, someone is asking whether some of these methods can be practically implemented as a method of stunning prior to slaughter, which I believe Heft has done some of that.
There's work being done for both pigs and poultry. There's a lot of interest right now in the poultry world. And there's a large study coming out from Rice in Sweden in the next few months. But yes, there's a great interest in it, especially with the concern with CO2 in Europe and swine.
Okay, great. Another question we have here is, what is the largest diameter nitrogen bubbles that you theoretically can attain? And is there any advantage to using smaller sized bubbles, or is it kind of the bigger the bubble size, the better for animal welfare?
Well, it's a balancing act. The bigger the bubble size, the less flowability, and the drier the bubble. So it's a if you're in a containerized system like heft, they can use a much larger bubble because they don't need to cover the area. If you're a live tech system, you use a little bit smaller bubble because then it flows better throughout the facility and gives you complete coverage. So there's a balancing act there, but we're learning more and more about that. And there are other ways of placement of foam generators and how we operate those. How do you do them simultaneously, sequentially? How do you make because what you do is you create a bow wave in the building, and so it builds up and then it falls over the animals. And the benefit of that is there is no negative effect to the animals that are uncovered. So not like CO2 where there's an acidic gas or VSD plus where there's a heat issue. The other animals are unaffected. So it's really that you want that wave, you want to depopulate the ones and then it waves over. So you're not doing nice an even buildup. You want to keep as many animals out of it as possible until you cover them. And you want to
Okay,
make sure they're covered. Once they're covered, they stay covered.
great. And then this is a multi-part question, so I'm going to try to give you one piece at a time to make sure we don't lose anything. The first part is, with the nitrogen foam, or specifically high expansion nitrogen foam, how is it possible to differentiate anoxic death from death via airway occlusion?
We have there's been the first one is measurement of the oxygen level, and it's always less than 1%. It's usually in the 0.2s. The second is there's been a significant amount of necropsies completed on those animals. We have learned that you do not move the animal because especially with swine, if you move them, you can cause ingestion of the foam. So we've now we it doesn't take long for the foam to dewater, and then we blow out the foam and then do necropsies in position.
And in related to this question, the veterinarian was asking uh, how the time to loss of posture compares with air-based foam, and they're specifically asking about they heard about a high expansion air-based foam used for depopulation, and were wondering about that comparison. But I hadn't heard of a high expansion air-based foam.
It's always been medium density foam or low density foam that I'm aware of.
So comparing time to loss of posture between high expansion nitrogen foam and the water-based medium expansion foam used widely in the US, how do those times to loss of posture compare for the different
It's a more
species?
rapid loss of posture and part of that is due to the rapid buildup of foam volume. You can cover those animals much more quickly with a high expansion foam.
Okay. And then does the high expansion foam use PFAS? And if
No.
not, what is the surfactant, if you know?
Surfactants are all proprietary. Live Tech, I can give you the brands, but they're all PFAS free. Um, but I would have to give you the brand and because each surfactant's slightly different. And each company has their recommended surfactant. Live Techs and AESs are commercially available, where Heft is a proprietary foam developed and made specifically for them.
Okay. Now I'm going to transition over to questions about the nitrogen gassing. I know there have been a lot more questions that have rolled in, but maybe you'll be willing to give some answers after the webinar. But just in the interest of time, I'll switch to some of these. One person is asking whether any nitrogen systems are being used in the US by companies to eliminate PRRS on a site.
eliminate PERS.
Mhm.
Um, we've done some testing with it. I wouldn't say it's commercially being used. Most of those would be CO2 or, but there, that is a new technology that is coming along. Um,
And
honestly,
then,
it's a funding issue. It's always a funding issue.
so the nitrogen gassing trailers up so far really are just being used in Canada.
Yes, they have been
Okay.
used extensively in Canada.
And then this is related to nitrogen whole house gassing. Will the HDPE pipes become brittle after a single use? And will HDPE withstand multiple uses of liquid nitrogen?
We've used it, the same pipe, for up to 20 times. Italy's used it over 30 times. It shrinks and then it re-expands to its regular length. The only time we've seen it fail is when a liquid nitrogen transport trailer drives over it while it's still frozen. That will cause it to fail.
Okay. And what level of barn sealing is required for whole house nitrogen gassing?
That's all depend on the barn and the ventilation system. I love chimney vent systems because they require no sealing on the advanced chimney vents. You just um, some are some require a great deal of sealing because they're just a very porous barn. You can we actually you can overseal the building, and so we don't we want venting to be up high and allow oxygen to escape.
Okay.
So it's not as much as everybody thinks. Let's put it that way.
So compared to whole house gassing with CO2 or compared to
It's
ventilation
very equivalent
shutdown?
to a CO2
Okay.
for egg layers. The difference with CO2, we only take it slightly above the animals, where nitrogen whole house gassing, and part of it is we're still very conservative. When we started this, we were doing a dwell time of 30 minutes, 60 minutes, very conservative, want to make sure everything was dead. And we've still been filling the entire building with nitrogen gas, bring the oxygen level at the ceiling down to below 5%, above any animal at 3%. I think we'll start doing some testing in just how high we have to be at 3% or below.
Have you performed whole house gassing with nitrogen on multi-story facilities?
Yes.
Anything else that is working the same way as the others, or are there any concerns with that?
It de Multi-story can mean a lot of things. We have done it where enriched cages have been retrofitted and taken a pit, and so they filled the pit, and then they now have cages in both the pit and the barn above, and that worked fine, no problem. Some that have solid floors between, we have to look at what the flooring material is because we're using retained heat in the building. And so if it's plywood, it can be different than if it's concrete. There's just different aspects that require evaluation.
And how do you avoid freezing birds near the LIN injection sites or near hoses if they are floor raised birds?
It's all about the balance of liquid injection rate to vaporization. And you actually can see when you're doing it properly, there's no liquid anywhere on the floor, no liquid coming out. It comes out, and because of the vaporization rate and its expansion, it actually aims upward and creates a little kind of a tornado. You can actually see it on the video in thermal cameras of a little tornado. So it doesn't blow directly out, it blows up. And we are very careful. We have very specific parameters on where we place injection points. It's not a random thing. We place them, we have certain distances from any equipment. Um, if it's an alleyway, it's very simple. If it's floor-reared birds, honestly, most of the floor-reared birds will move away from it, and you'll see a radius around it. We have looked at blocking it off, but actually have not found that necessary. Uh,
So it's kind of getting
based on,
cold slowly enough that they can move away.
well, and it aims, we do have a 5-degree angle. We have a 5-degree angle for a specific reason to create that tornado going upwards. And that is why we're doing so much of the body temperature monitoring and the implant internal body temperature to verify that. That was our biggest concern, to be honest. And we are looking at in this next project looking at vaporization and maybe use of an internal manifold where we can bring the temperature up. We still want it cold, but not as cold, maybe just below zero, and inject it at that rate. But there's a concern you can make the system so complicated and so expensive it can't be used. So it's a balancing act of understanding what's most critical.
One person was asking about the birds becoming cyanotic when you're doing the whole house gassing with nitrogen. It does make sense that toward the end they would be, clearly be cyanotic. Are you noticing their combs turning that bluish tinge early on, or is
No.
it more toward when they're losing posture?
Yeah, it's you, and we've had veterinarians do all kinds of, necropsies and analysis, and we're not seeing a tremendous amount of it, if any of it, because we try to, and we're actually looking at some of our flow rates that we may change when we get to 10% to try to decrease that time from 10 to 6%. By 6%, they're all out. There's no question. A lot of times with turkeys, we're out at 8%, 100% loss of sensibility. So it's just that very little time. And that often is 1-2 minutes time frame. So that is one of those variations that as we've gotten better at controlling the flow rate coming from the trailers, we're playing with now. We now are using a metering system on the trucks that tells us exactly what the flow rate is, what the pressure rate minute by minute by minute, versus when we started this older trucks, we were just using the valving system. So there's a lot of things we've made improvements over the last 3 years.
Right. I think I'll maybe just do two more in the interest of time, and then we'll try to keep a record of these others, and can potentially, if there's some more in-depth questions, can contact you all after the webinar. But second to last one, do you think a shorter injection time, like 30 to 60 minutes, is better than a longer injection time, like 60 to 90 minutes, to reduce the risk of freezing of birds?
It's again that balancing act. We think 60 minutes is the number we've come up with. We find very little risk. Our first one, we injected in less than 10 minutes. And we dropped temperatures very rapidly. It was not on purpose. There was some issues, but we have done a range of injections. And I've asked the Italians why they do that 90 minutes. And part of it is they have a different transport trailer systems, but also some of their barns are they're retrofitted very old foundations, and they're worried about the stone foundation getting cracking. We think we've hit up on that 60 minutes as being a good balancing point. But it will cost you some gas, some nitrogen. But we also look at what is the timing if we're in a HPAI response. How long does it take to do a building? Oh.
And then this one is going back to the foam systems, and I'll just have this be our last question, and then we can wrap up here. What is the average time of stability of the various foam systems that impacts getting into the sheds post-depopulation? And how much is the liquid volume that is left either in the sheds or the containers, I suppose, after the foam dewaters?
Yeah, dewatering, it will harden. If we just look at barns, because the HEF system's a little different because of the nitrogen injection, and it pops the bubbles very rapidly. So that's slightly different. It takes about 15 minutes to dewater, to the point of where it's a hard, crystal foam. And then you can enter we use a leaf blower, battery operated leaf blowers. And you can move around. The worst thing you can do is go in there with a hose and try to wash it, because then you just make more bubbles. And then how long it lasts really depends on the environment. If you turn the ventilation on, you can knock it down very, very quickly. If it's a naturally ventilated building with no breeze, it may take longer. There's just a lot of factors in there. But you can get in those barns very quickly to check animals, if you wish.
Well, thank you so much for sharing your expertise with us about these topics. And thank you everyone who attended this important and timely webinar. We are going to be posting a recording of today's webinar on VAFAW's website in the coming days. So if you missed part of it, we already have had one person ask about your slides because there's so much great information in there. You can find the recording on our website. We'll also be sending out certificates of participation with CE credit over the next week to veterinarians and veterinary technicians who've attended. And just a reminder to please fill out the short survey that will show up on your screen after the webinar ends. And finally, if you're not already a VAFA member, please consider joining. The first year of membership is free. And if you have any questions, please don't hesitate to email us at info@vafa.org. Thank you again for joining.